All right, we're going to be mapping the dark matter of knowledge. And yeah, it sounds a bit out there, but we're about to go on this incredible expedition. Not to some far off galaxy, but right into the universe of ideas. We're literally going hunting for the dark matter of what we as humans actually know.
This quote right here, it just nails the whole idea. Think about it. We have physical dark matter, right? This invisible scaffolding that holds the entire cosmos together. Well, the idea is there's something just like that for our scientific knowledge. It's this unseen structure, this web of how and why that connects all the facts we learn. And the crazy part? For the most part, it's completely, totally unmapped.
So, what is this invisible dark matter of knowledge? I mean, where did it even go? Let's dig in and try to solve this thing. Okay, think about how you use something like Wikipedia. It's kind of like looking at a map that only shows the big cities. You see New York, you see London, but you have absolutely no idea about all the roads, the shipping lanes, the flight paths that actually connect them. Well, this new approach, it's not about just showing you the cities, the facts. It's about mapping all the roads, all the lines of reasoning that get you from one place to another. And, there's a reason those roads are missing. It's got a name, actually: radical compression of reasoning. For literally centuries, to save space, to save time, we've just summarized. We publish the final theorem, but we leave out the 10 pages of math that got us there. We record the what, and we just toss out the why. And yeah, it's efficient, I guess, but it leaves our entire knowledge base super brittle and almost impossible to truly verify.
Now, when you see a problem like this, a huge gap in our information, your mind probably jumps straight to AI, right? I mean, why can't our super powerful new tools just fill in these gaps for us? Well, as it turns out, it's not quite that simple.
I mean, it seems so obvious, doesn't it? If we humans left out all the reasoning, let's just ask a big LLM to write it all back in and create a better encyclopedia. But yeah, that idea runs smack into a huge fundamental wall. Yeah, there are two really big problems here. First, there's what they call inherited blindness. See, our AIs are trained on the internet, which is just full of our compressed, fact-only writing style, so they learn our bad habits. They literally can't see the dark matter because we never showed it to them in the first place. And the second problem is way, way more dangerous: hallucinations. These things can confidently just make stuff up. Plausible-sounding facts, fake reasoning, and that is the absolute last thing you want when you're trying to build a trustworthy scientific knowledge base. Okay, so if we can't just use AI on our existing data, what's the plan? Well, it means we have to create this dark matter of reasoning completely from scratch. And the key here, the most crucial part, is that it has to be done systematically, and above all else, it has to be verifiable. And the solution they came up with is just brilliant. It's a workflow built around an AI called the Socrates agent. So here's how it works. First, it basically takes about 200 university-level courses to get the lay of the land. Then it starts generating millions of really deep first principles questions. But here's the genius part. It doesn't just ask one AI. It gives the exact same question to multiple totally different AI models. A line of reasoning is only accepted if they all independently come up with the same answer. It's this incredible filter for making sure the information is actually correct. And we really need to talk about the scale of this thing because it is just immense. We're not talking about a couple thousand questions here, no. The Socrates agent generated around 3 million of these deep, fundamental questions. It's just a colossal effort to map out all those hidden connections in science, right from the very basics. So what do you get at the end of all that? Well, you get something completely new. It's called a long chain of thought knowledge base, or LCoT for short. And what that means is it's a library that isn't made of just facts. No, every single entry is a complete, verifiable, step-by-step line of reasoning. That dark matter we've been talking about, it's finally being brought into the light. Having this incredible new database of pure reasoning is, a huge breakthrough. But let's be real, a giant library isn't much use if you can't find anything in it, right? So that brings us to the second part of this whole solution. How do you actually make this stuff useful? And this is where we see a huge fundamental shift in how we even look for information. Imagine you do a traditional search for a term like instanton. You'll get a definition, right? The destination. Inverse knowledge search completely flips that on its head. You ask it to show you all the different reasoning paths that lead to the idea of an instanton. It'll pull from quantum mechanics, from cosmology, from pure math. You're not just learning what it is anymore, you're finally discovering why it is. So to handle this new kind of search, there's another AI in the mix called the Plato agent. And you can really think of Plato as a master storyteller. Its whole job is to go into that database, grab all of those verified reasoning chains, and then narrate them, weaving them all together into one single, coherent story that you can actually understand. So what happens when you combine this massive, verifiable knowledge base of pure reasoning with a super powerful AI synthesizer? Well, you don't just get a small improvement on what we already have. You get something totally different, a completely new kind of encyclopedia.
And it's called SciencePedia. The first version is already up and running with about 200,000 entries. The really key thing to get here is that every single article isn't just written. It's synthesized directly from that rock-solid foundation of verified reasoning. Trust is baked right in from the ground up.
And when you look at the results, they're pretty compelling. Articles from SciencePedia have a much higher knowledge point density. So what does that mean? In simple terms, they're just packed with way more unique, learnable ideas than an article a normal AI would write. You just get more out of them. They're richer, they're more informative. But here's what's even more important. Because every single statement is grounded in that pre-verified knowledge base, the number of factual errors just plummets. It's a direct assault on the whole AI hallucination problem, and the result is content that is just so much more reliable and trustworthy. When you really get down to it, this whole project isn't just about building a better Wikipedia. That's not the goal. This entire framework is built for discovery, by mapping the roads, not just the cities. It lets us finally see all the surprising, profound highways of thought that connect, say, physics to biology or math to engineering. You know, for centuries, this huge network connecting all of our knowledge has been totally invisible to us. But now we finally have a map. So the big question is, what new continents of understanding are we about to find? What kind of breakthroughs are just hiding there in plain sight, waiting for someone to finally trace the connection?